Good morning. In the last period, we discussed the even function, about the parity of a function. Now we have the odd function. First, we have f is said to be odd if the domain is centered at O and f of minus x equal minus f of x. And if the function is odd, then O, which is the origin, is a center of symmetry of the curve when we draw the function graphically. Example here, f of x equal x cubed plus 5x. First condition, the domain, it is a polynomial function, then the domain is minus infinity plus infinity. Minus infinity plus infinity is centered at any real number, then this is centered at 0. The first condition is done. The second condition, f of minus x. F of minus x power 3 plus 5 times minus x. Minus with odd exponent, it stays minus x power 3. Plus times minus equal minus 5x. We can see that this function is not as f of x. It's not the same, then it's not even. Now, to check if it is odd or not, we take minus common. Put minus outside, x cubed plus 5x. Now we can see that it's equal minus, and the function inside is the same as f of x. So f of minus x is equal to minus f of x, then f is odd. Here we have domain is minus infinity plus infinity. It is centered at 0. Graphically, O is the center of symmetry. In this case, if we take any x and minus x, what do we mean by f of x? F of minus x equal minus f of x. If xy belongs to the curve, then minus x minus y belong to the curve. Since in case of even, f of 2 equal to 3 and f of minus 2 equal to 3, we have f of minus x equal f of x. If we take two opposite abscissas, they have same image, which is f of 2 and f of minus 2. In case of even. In odd, f of 2 equal to 3, then f of minus 2 is equal to minus 3. Here we have f of minus x is equal to minus f of x. This is the difference between even function and odd function. In odd function, we have O is the center of symmetry. We can see that each x and its opposite, the image is at equal distance from the x-axis. Here we have the distance, for example, 2. Here the distance is 2. Note, an important note. Even or odd function should satisfy two conditions. The domain should be centered at 0 in both odd and even, and we have the second condition should be verified. For example here, f of x equal x squared plus 3. Here we take the domain only minus 1, 3. Part 1. The domain is centered at 0, and we have second part, second condition, f of minus x. To calculate f of minus x, which is minus x squared plus 3, minus with even exponent, it becomes plus, then the function stays the same, so f of minus x equal f of x. This condition should be done with the first one. Here we can't say that f is even, since this interval, which is minus 1, 3, to find the center of this interval, it is minus 1 plus 3 over 2 equal 2 over 2, it's equal to 1. It's not centered at 0, then this function is not even. So to have a function even or odd, the two conditions should be verified. Exercise: determine the domain and study the parity. The parity, it means even or odd or neither of the following functions. F of x equal x power 5 minus x. It is a polynomial function. Domain minus infinity plus infinity. Domain is centered at 0. The first condition is done. We start by f of minus x. F of minus x power 5 minus x. Minus with odd exponent, it stays minus. Minus times minus equal to plus. We can see that this function is not the same as f of x. It's not even. To check if it is odd or not, we take minus common. X power 5, when we take minus, we change the signs inside. Minus 5. Minus x, not minus 5. Minus x equal x power 5 minus x, it is f of x. So the second condition is done, then f is odd. Another example, we have x squared plus x. It's also a polynomial function. The domain is minus infinity plus infinity. Domain is centered at 0. F of minus x equal minus x squared plus minus x. Minus with even exponent, it becomes a plus. Here you have minus. We can see that this function is not the same. X squared minus x, here we have x squared plus x. This is different than f of x. Try to take minus as a common, minus. The first one becomes minus x squared, the second one becomes a plus x. And also, to check if it is equal to minus f of x, also it is different than minus f of x. Here we have minus, here we have plus. Then this function f is not even and not odd. The second condition is not verified in both cases. Last example, f of x equal x plus 5 over x plus 2. Domain of definition, we have x plus 2. The denominator, it is a rational function. X not equal to minus 2. It's r except minus 2 as an interval. Minus infinity minus 2 union minus 2 plus infinity. This function is centered at minus 2. So no need for the second condition. It's not centered at 0. it's not even, and it's not odd. Since it's not centered at 0, the first condition is not verified.